Well, we're gonna go for this again. I just had a conversation with another math teacher about scope and sequence and the math program, feeling kind of inspired and lost. So I want to try and just find my way, and maybe something good will come of it. Anyway, I just gotta, do some teachy preparation stuff, and maybe something good will come. So I'm gonna do some algebra 2. There is an introductory chapter. It's like number theory and hey, remember how to do math, that sort of thing. And kind of afraid of skimming over it, particularly because the end of the last school year was so messed up. So I'm going to try and just break out of the section by section presentation that the book lends itself to, and try to make a more unit-based global approach to it. So let me see what I can do. I'm going to put that off to the side. Hold on. There you go. And yeah, I think I'm gonna see if I can't just make a hyperdoc out of these, and then maybe I've got something I can do with Google Slides. I did have an idea about that. Anyway, here goes. I'm going to just troll through this first chapter looking for all the juicy bits. I think I'm going to nab all the vocab terms and everything that they put in a box except for order of operations, because I had my own approach for that. Okay, let's see here. Variables, algebraic expressions. No, that's all part of my first lesson. So that one's good. Formula. No, I guess I might as well. Let me see if I can. Oh, good, I can select text. Awesome. Why won't you let me do it? There we go. Oh, I see. Those are images. Okay. Variable. I guess I should say variables, because the definition is plural, so I'll make the term plural. And quantities. Alright, so let's see. Algebraic expression. That would be expressions that contain at least one variable. Well, that's terrible because it didn't actually define expression. Is there a definition of expression here? Huh. Just going to assume the term expression. Look at this. It defines algebraic expression with the word expression. That's no good. Okay, let's see here. Term a symbol, number, or variable. Let's see. Oh, well, there we go. In an expression. That can be combined with other terms to form an expression. Expressions that contain at least one variable. I think we'll just have to do that. Here's my analogy. Term is to expression as word is to clause. And an equation would be an expression with an equal sign. Okay, let me see here. Moving on. Algebraic expression. Formula. Equation an expression with an equal sign. Didn't pick it up. An expression with an equal sign. Maybe not. That's too bad. A formula is a mathematical sentence that expresses the relationship between certain quantities. Seems like the difference between a formula and an equation is context. Use a formula and then exercises. Okay. This was the real part I was interested in. So, real numbers are rational or irrational. Okay. So, I'm going to need to build a lesson on that number theory. So, let's see here. Real numbers, rational, irrational. It's ironic that I'd put a slash between those. Got it. Okay, so I guess I can take this just because I want that notation. Are the reals, key are the rationals. Man, it is really strange having z be integers when you use it for complex numbers later. Come on, math, get your act together. All right, let's see then. This table. Let me see. Does this copy? No, this is an image. Can I copy the image? Oh, no, it's text. I see. All right, I wonder what it looks like if I copy that. Ooh, what's it I just copy? Oh my goodness. A lot more than I wanted. All right, never mind. Okay, so commutative property, associative, identity, inverse, distributive. So real number properties. Okay, so just in case it looks like I'm just reading a textbook and writing random words from it, what I'm trying to do is gut the chapter so I can get out all of the nuggets of mathematics so that I can repackage it into a more holistic lesson that doesn't just go lesson, 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 you know, like section, section, section. All right, so I got a couple more definitions here. Open sentence. That is a mathematical sentence containing one or more variables. And then, according to this, an equation is a mathematical sentence stating that two mathematical expressions are equal. All right, I think I can change this. A mathematical sentence. Okay, let me reform this then. I'm going to make this a table. Insert table to... All right, here we go. Math over this side. No, put English on the left because it's the familiar one. Here's math. So I've got term, that's a word, expression, that is a clause or a phrase. And you know what? I should use phrase because clauses have verbs. Also, I think clauses are less familiar to students than phrases. And then equation is a sentence. Two phrases linked by a verb or something. All right, so here we go. Mathematical sentence stating that two mathematical expressions are equal. Okay. So that's interesting because a formula is just a different take on an equation then. If an equation says this expression is equal to this expression, a formula is basically this expression is equal to this expression, but interpret this expression as a series of like interpret it. Nah, I don't know. I'll sort this out later. Okay, where was I? Solution. Solution. That would be sentences are neither true nor false till the variables have been replaced by numbers. Each replacement results in a true sentence. A value for a variable that makes an equation true. It says open sentence, but I don't know. All right. Properties of equality. So let's see. Let me make sure I categorize these right. These are number properties. Where? Oh, here we are. Yeah, number properties. There we go. And now properties of equality. All right, let's see here. Properties of equality. All right, just shared that online. We'll see if anybody comes. Okay, let's see. All right, so properties of equality. Let's get down there. Properties of equality. Here we are. Reflexive. Oops. Symmetric. Transitive substitution. All right, let's see what else we have in here. It's nice that I'm writing them down in the order that they occur in the text. So, oh, look at that. They're interpreting it like a sentence. Good for you, math book. Okay, let's see here. Exercises. Good. Absolute value. All right, looks like we're going to have the term magnitude here somewhere. Absolute value. And that is numbers distance from 0 on the number line, aka magnitude. Magnitude? Sure. Magnitude. Close quotes on that. Okay, let's see now. So, in case you've just joined, what I am doing is, the last school year ended pretty dramatically, and it's not likely that everybody coming into Algebra 2 had a very good time in either well, they were coming out of geometry. So actually, never mind. Everybody had the same end of Algebra 1. But just talking with another more senior math teacher, people's ability to do math is usually compromised at the beginning of the year because they had a whole summer to forget. In this case, it's almost like they had a 7-month summer. But got to make sure that we cover all the number theory bases. Empty set. Really? Empty set. What's the context that it's defining that? Some equations contain absolute value expressions. The definition of absolute values used in solving these. Oh, that's where you can't see it. Let me see. Second case. Yeah, anyway, I went with the last stream with a plan. This one, less of a plan. I thought it's probably kind of dumb to watch someone figure something out. I had already figured out the last one, and I was executing the plan. This one, I did not have it figured out ahead of time, so probably going to be a lot of hms and haws and dumb pauses that I end up not getting anything out of. So, you know, just so you know. The second case is often written. Part of the reason I'm doing this is because the stakes are a little higher. If I get distracted and like just go on Twitter or something, it's, you know, people will see. It really does help having people to look over your shoulder. All right, let's see. Because the absolute value of a number is always positive or 0, an equation like that is never true. I see, it has no solution. Oh, that really seems... I don't really see the necessity of saying what empty set... I mean, I don't need to define empty set if I'm not doing sets. I'm going to skip that. I did do a little bit of set theory for a pre-algebra class because it made it easier to help them with least common multiples and greatest common factors. Okay, so trichotomy property. Why the heck does this need a name? Trichotomy. It sounds like a weird surgery. Trichotomy property. Two value. This is so dumb. Two values may. Value may be greater than, equal to, or less than another. Okay. Addition. So was there an addition property of equality? Okay, so this is messed up. There's an addition property of inequality and a subtraction property of inequality. That should have been introduced after the addition property of equality and the subtraction property of equality, and I don't believe it was. Where are those properties of equality? Oops, that wasn't the one I wanted to zoom in on. I wanted to zoom in on this one. There we go. Where are those properties of equality? Property order. There was a box of properties, and anytime there's a box of properties, I'd expect to find it in there. Did I go too far? No, I didn't go too far. So this, where was it? Here it is. Oh, there was. I missed it. All right, where it was right after that. I see. All right, I did miss it. Thank goodness I'm reading so carefully. Addition and subtraction properties of equality. Why do we give things these names? Addition and subtraction property of equality. Okay, so I can pretty much guarantee that no high schooler ever cares about this. You can do the same thing to both sides. It makes way more sense to express this like visually or conceptually than to try to do it analytically like this. The only reason you'd ever want it to be analytical that I can think of is if it needs to be like some axiom in a deductive proof. For any real numbers a, b, and c, if a equals b. Okay, multiplication and division properties of equality. Addition and subtraction property of equality. Multiplication and division property of equality. I see. Okay, and they've got the same thing for an inequality, right? Let's see, where was I on that? Here we go. Addition property of inequality, subtraction property of inequality. Okay, so that would have been the next thing in order. I'm just going to add in to these. All right, so it looks like there's a bunch of properties, a bunch of terms. Let's see. Oop. Oh, where'd I go? Oh. That happens sometimes. My mouse wheel just like randomly goes down. Oh, never mind. It didn't. Okay, so multiplication property of inequality, division property of inequality. Ah, got it. And here's where it flips. Okay, and it is different when it is negative because it makes the got it. It makes the inequality flip. When multiplying, dividing by a negative, the inequality flips. Got it. The solution of an inequality. Okay, here's set builder notation. For example, the solution set. Got it. Okay, so we are going to want to have set builder notation. Set builder notation including empty set. All right, that's why it introduced it. There we go. Got some context. Interval notation. Hooray! All right, well, I'm just listening to this stream as I'm doing it. This is really boring. Just watching a dude work. So, yeah. This is quality content. This is why my channel's blowing up. Compound inequality. There we go. Compound inequalities. compound inequality consists of two inequalities joined by the word and. Thank you, Harry. Inequalities joined by the word and the word or. To solve a compound inequality, you must solve each part. The graph of the compound inequality containing and is the. Got it. Okay, this is perfect. So it looks like set theory is going to be a part of this. So I happen to have a lesson on sets. Let me see if I can find that. I did it at this school. I might still have it here. Set. Yes. Sets, intersections, and unions. No, this is the exercises. All right, well, I still want that. So let me see. I'm going to share this with myself. Here we go. Here's your work. Okay, so yes. So this is a exercise sheet that I made for practicing intersections and unions. All right, now I gotta find the Okay, I did something in Google Docs with it. Doggone, where is it? Let me just search set theory, see if. Oh no. Set theory, intersections, union. Ah, this might be it right here. Please, 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 please. Maybe. Yeah. Okay. So I had more than this. I did have more than this. Where is that? All right, I might have to look for that later. But I thought I had a whole sheet of this. All right, well, I guess I'm just gonna copy this over, I guess. Set builder notation, interval notation. Ta-da! All right, so imported my own work. Boy, that's killing me that I don't know where that is. I have to find that. There were some things that I did on Google Drive, and there were some things that I did on my hard drive of my work computer, and I would have transferred that. I just I will give it one look. Let me see here. You know what? Never mind. That's just gonna distract and take a long time. All right, getting back to here. What else do I have in here? So intersection. Oops. Oh, I lost my place. Here we are. So got intersection and union. That's covered in there. Okay. Oh, that's it. Okay, good. So good. So this is all the good stuff. This is all the stuff from the first chapter. So what I want to do is to build off of my first lesson. Man, how long did that take? See, yeah, that took half an hour. I want to take all this and try to build some formative lessons out of this that aren't necessarily like a section by section kind of thing. Would be very nice to be able to use the exercises though. So I think I'm gonna go back up to section 2, see what kind of exercises I have to work with. Here we are, properties of real numbers. Okay, so I think this would be the best place to start. Okay, so reals, rationals, irrationals. All right, so how to express that in a way that's going to be goods coming in. All right, so if I go back to this math as a language, I've already established that numbers are kind of like the nouns of the mathematical language. Variables are kind of like pronouns, but maybe those categories don't exactly fit. But the point is that they are the objects. They are the noumenon or whatever of the mathematical landscape. They're the objects and the subjects. So I guess I have got some categories to work with here. So let's see, am I in the wrong drive? All right, so I guess I will go back this way. All right, so I want a new Google slide. All right, so it's a shared folder, I see. All right, let's do this thing. Okay, if you wanted to see a lesson get made, here I go. So the info that I want to try to capture is types of numbers. This is not an entire class all to itself, but yeah. Okay, so I think I'm going to need to go full screen with this. So reals, rationals, irrationals, integers, wholes, naturals. All right. What are numbers? All right, joke subtitle. What are numbers? Somehow count. You can count on them. Nah. And can I have yours? No, that might be a bad joke. Bad joke. All right, what are numbers? What are numbers? I don't know, but can I have yours? So stupid. All right, so numbers are nouns. Numbers are like nouns of mathematical sentences. I cannot type. Sentences. They are the subjects and objects. Okay. We use numbers or maybe I should say numbers are useful to model, to represent. Numbers are useful. Oh, okay. I'm gonna borrow something from Stephen Strogatz now. Numbers are useful. By the way, if you don't know who Stephen Strogatz is, like, what are you even doing watching me playing math lessons? Numbers are useful for expressing numerical quantity. All right, graphic time. I wonder if this clip is out there. So there is this clip from Sesame Street that I learned about from it was some series of essays or something written by Steven Strogatz, and there was some fish restaurant. It was for penguins, and the penguins kept calling in their order for fish, and of course they all want fish because they're penguins, and the person taking the order is just like fish, 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 fish. Okay, the order is fish, 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 and the whole point was, why don't you just say 6 fish? That was the idea. So I think that's the best way to get this across. Numbers are useful for expressing quantity. All right, so I'm gonna have to just represent this graphically. So let me see if I can. Maybe I should do this with insert. Oh, yeah, I'll do it with a special character. Insert special character. Just do something that's definitely a picture. A check mark. There we go. All right, I think this would actually be good to do with 2 different text boxes. All right, so this one's going to take up this side, and it's going to be like a versus. Okay. Check. Okay. It's funny. Check. Check, check. 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 It sounds like a sound guy. Check, 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 check. All right, so same thing, but 1 check, 2 checks, 3 checks, 4 checks. Yeah, there you go. 1, 2, 3, 4. The idea being, oh wait, why did they take up? Oh, I see. I didn't line them up vertically. Okay, so yeah, that's the idea. That you can understand that there is something the same about 4 of these and 4 of those. There's a 4-ness to them that that we're trying to express with a number. Okay, numbers are nouns are expressing quantity. There is a 4-ness to 4 things. Okay, at this point, I'm not even like borrowing from Mr. Strogatz. I'm just stealing. But you know, I cited my source. So, all right, numbers are nouns. Got it. All right. Let me go ahead. So these would be natural numbers. Yeah, those are the natural numbers. I had better double check that. Natural numbers. They start at 1 and they're the integers from, yeah, good. Sometimes 0. Okay, so natural, all right, natural numbers. Natural numbers are, what's the difference between a whole number and a natural number? I think whole number might not be a rigorous definition, or whole numbers. Let's just include the negatives. It looks like it's just a synonym for integer. Whole numbers and integers. Is there a difference? So apparently whole numbers include 0. What the heck, man? So apparently whole number, counting number, and natural numbers are all just like 3 terms for almost the same thing. Okay, so natural numbers can express how many of a particular object you have. You know what? That really should be at the bottom of this. Yeah, this should be the illustration for natural numbers. Yeah, that was a mistake. Oh, nuts. Now I don't know what to do on this slide. Yeah. If I'm going to have an example of a number, I need to be able to also explain why that category exists. What are numbers? Numbers are the nouns of mathematical sentences. There is useful for expressing quantity. This was supposed to go with the picture, so I think I'm going to do this instead. Useful for expressing quantity as there are different categories of numbers useful for describing. You know what? I'm not going to overdo this slide. I think I'd rather have it empty than full of nonsense. I don't like it empty, but that's the kind of dithering around that I don't really want to do. Natural numbers can express how many of a particular object you have. So, all right, here's an interesting question. Can you have 0 of an object? Does 0 count as a natural number? Okay. Pear Deck time. So open Pear Deck add-on. I'm going to make this be a text question where people can answer with text, because ordinarily this would be the kind of thing I would just ask the class. But if I'm doing this remotely, I'd like them to be able to write their response. So let me copy this text box, put the question at the bottom. Is 0 a natural number? And I'm sure we could spend 5 minutes discussing that. Students, write your response. Okay. Yeah, well, 0 doesn't break all the rules, but it certainly does break many of them. But okay, so here's the thing about 0 breaking the rules. You know, the keep you up at 2 in the morning question, is water wet? The thing is that a lot of the definitions of terms are not intended to apply to that thing itself. Like, we call something wet because water is on it. Water was not supposed to be the subject. So, you can bend the definition to include it, but maybe you're just, I don't know, doing something weird. All right, so natural numbers can express how many of a particular object you have. Okay, that's completely concrete. After this, I believe the next category, did I close that tab? No, I didn't. It's still here. So reals, see, would it be rationals? What's oh, I closed the textbook, that's why. All right, so I'm gonna open my textbook back up. I need to make sure that I'm going out in order. There's my chapter 1 of this textbook. I think it might be integers. Yeah, it should be integers. But just leave it to me to screw up something easy. Just go straight to section 2. You see that graphic, the Venn diagram. There we go. Holes. Ugh. Whole numbers. What is the usefulness of a set of numbers? Okay, like the natural numbers has infinitely many members. It just doesn't include 0. We add 0 and we need to call it a new set. Like, oh my gosh, so annoying. I'm not giving whole numbers its own slide. That's just, no, just not doing it. Whole numbers, you don't get your own slide. I'm going straight to integers. Is integers the integers the next one? Z. Integers. All right. So now I need so the difference between an integer and a whole number is that the integers contain the negatives. There are no you can't have a negative number of an object. So integers. Integers are like the natural numbers, but it includes the negatives. Since you can't have a negative number of objects, it is better representative of a situation where you have an equilibrium and you can adjust both ways. It's better representative of a symmetric scale with a central equilibrium. Okay, so good example of this would be kind of like let's see, having a difference is good as a model for subtraction, like 8 people on this team, 9 people on this team. But I don't think that's gonna do so well with a central equilibrium. There was a show I watched. I can't remember the name of it. It was some, like, you know, teach math in space show where there was like a space skyscraper with like a zero, like with like a ground floor, and you could take the elevator up or take the elevator down. It was basically a model of a number line. Oh, I know. I'll get a picture of a globe with a center. I'm going to take out equilibrium with a center. All right, so this is great. All right, so lines of, I want to do longitude. Let me see if I can get a nice close-up of that. I might need to actually get to a picture of a map. So I'm thinking of lines of longitude on either side of the prime meridian. You know what? I don't know. I might get a better picture because everything's always centered on the equator. I might want to do lines of latitude. Just wanted to have it go from left to right, but maybe I can't be a chooser. All right, let me see here. Lines of latitude. I just want a nice close-up of the globe where it's zoomed in enough that it doesn't look round. Yeah, flat Earth. All right, let's see. I mean, I like this. Let me see if this search will come up with something. Lines of latitude. You know what? I think I'm going to go with this one. It's the right aspect ratio. Ooh, it's hard to read. Oh, those portable network graphics. Alright, now I'm going to have to go with something that actually has a background that lets me read that. Oh yeah, you heard that. Yeah, I said zoomed in enough so that it looks flat. So it doesn't look round. Man, I don't know if I'm going to get better than that. Hey, well, if I can't get better than that, then I'm just going to suck it up. All right. So the idea is that the equator is like the center, and you could go 10 degrees above or 10 degrees below, but the point is you could go either way. That's the point. It's symmetric. Okay, you can't have a negative number of objects. It's better representative of a symmetric scale with the center. So here is the thing. People think about negative numbers like they are the evil twins of all the positive numbers, and that is just absolutely nonsense. They're just the numbers on the other side. Okay, so let's see. Natural numbers. Was that n? What's the symbol for... Ugh. Is it n, natural numbers? Come on. There we go. N. Yeah, all right. Natural numbers. N. Integers. I. Wait a minute. No, Z. Sorry. That's irrationals. Integers Z. So, all right. Next up is that the rationals? Oh, sorry. I keep closing my book. Rationals. Okay. So, rationals are good for comparisons. Yeah. Rationals. So what I love about rationals is the comparison of the root ratio. This actually might be... Let me see if there's something good here. Ratio. Let me see what the root is here. To reason or count. Good. Reckoning, numbering, calculation. Reasoning, judgment, understanding. Awesome. Okay, so there is a reason why ratio and rational are related to each other, because I like to think of a rational number as you need to be able to take two integers and like kind of compare them, almost like you have two ideas and you're trying to decide between them. You're being rational about it. So a rational number is one in which you can take two numbers and compare them to each other. All right, so man, what? Oh, okay. Then I already know what picture I'm going to use. Let me insert it now, just so I can commit to it. Image, search the web. So scales, weighing scales. I don't know. How to, there we go. Yeah, like that. That's not going to show up. I need, that's a good one. Okay. Integers are all different some integers are larger than others, and when you compare them consider the when you compare them proportionally, you may find a value that is not an integer, a rational number is any ratio in lowest terms of two non-zero integers. Rationals was Q. Why the heck is rationals Q? Because R was taken for reals? Yes, I think that's it. Okay. Okay. Okay, so a rational number then can also be any amount of a discrete substance. I'm going to add that. As in, you can have 1.5 gallons of something, but you can't have an irrational amount of something, because that, what is it, that value doesn't exist on the number line or something. Let me see how I can fit that in. I think I can make it fit here. I'm just copying the text box so I don't have to reformat it. You can measure a continuous substance, water, in any rational amount. Okay, hold on. I shouldn't say any rational amount, but maybe I should say that any measurement of a continuous substance is rational. Do you know what? I think that the correctness of that statement is not worth the awkwardness of the phrasing. You can only have objects in whole numbers, but you can measure a continuous substance like water in any rational amount. Okay, good. Be nice to have some more interaction here. Got it. All right, so another discussion thing here. Text. All right, another discussion question. I want some other things that can be measured. like this. Let me see if I can move that up. If I just shift that down, I can write it down there. What are some examples of, oops. That's how to move it down a little bit. What are some examples of quantities that are best represented like this? Another good example would be charge, electrical charge, because there are only integer charges, right? There is a fundamental unit of charge, and it could go one way or the other. So examples of quantities could be steps to the right, steps to the left, floors above, floors below. Okay, so rationals. Okay, I think this might be getting a bit abstract for examples. Okay, hold on a sec. All right, we'll do that going in reverse. After rationals. Okay. Should I go to irrationals next or reals? Considering that reals are just the rationals plus the irrationals, I guess I can just do them together. Wait, rationals are Q, right? Yeah. Oops. Okay. The reals. Real numbers include natural numbers, integers, rationals. Now I want something that distinguishes real numbers. There's got to be some characteristic of algebra that makes them stand out. It really stinks when your definition of a term is not something else. Like irrational numbers are just not rational. And basically real numbers are not complex. I kind of wanted to say reals is just the entire number line. So I'm not going to do reals. I'm going to do irrationals and then say this with everything else is the entire number line, and we call them reals. Irrational numbers. Irrational numbers cannot be expressed as a ratio of two integers. Okay. When written in decimal form, they are infinitely long and never repeat. As such, it is impossible to locate them on the number line. It's like they don't really have an address. Let's see. As such, it is impossible to express them except as the means by which to approach them. Yeah, so irrational numbers are crazy, but awesome. To say the square root of 2, you're not even like naming it. You're naming a relation. You're naming an integer and a process, and then just saying, you know, right? So the square root of 2. That's like referring to myself as my mother's son. Like, I didn't have my own name apparently. All right, so I think that'll just have to do. Let me see if I can. Oh, okay. So here's what I'll do. Shapes. Let's draw right triangle. Be isosceles, and I'll just put a couple labels here. This will be X. Let me make that bright so you can see it. You know what? No, I should make that be 1. All right, and then a question mark. The idea is, that's really small. If you tried to find the rational number, which is the answer to that, you would fail. In fact, you would end up in a contradiction. So the idea is, this has a length, so tell me what it is. I can't. The reason that you can't is because the value is just like unnameable. All right, so I'm going to put that in speaker notes. What is the length of the hypotenuse? There clearly is a length, but what is it? If you tried to find a ratio, find the answer as a ratio, you would fail. Okay, so clearly there is a length, but it is some sort of unnameable length. Hey, my brother just joined. What's up, Soma Diggs? Yeah, this is live right now. I'm at work. Yeah. It's pretty cool. Anyway, all right, now would be a good time for that Venn diagram. So real numbers are. All right, let me see if I can find that Venn diagram image. Search for my. I wonder if it's here. Venn diagram of numbers. Is that it right there? That might be it. Okay, that's not in English. What is that? Sanskrit? Hindi? I don't know. All right, so Thai. I have no idea what that language was. That was great. I might be able to just get one. Then, oh, you know what I should have searched for? I should have searched for like actual terms. Let's see, Venn diagram of integer, real, rational. That should come up with it. Dang it, I couldn't read anything. I thought maybe it was just doing it as a tree. So naturals, integers. Well, wait, are the irrationals there? They didn't even put the irrationals in. Come on, man. Insert image, search from web. I just want a Venn diagram of number theory. Is this just too much to ask? Real, rational. You know what? Maybe I should put it in symbols. R, I, Z, Q, N. Oh, figures. All right. All right. I'm gonna get that picture later then. The irrational numbers and the rational numbers, including the integers, and natural numbers, make up the entire number line. Okay. All the numbers on the line are considered a real number. So there's going to be complex numbers in a later chapter, and just like people have this idea that negative numbers are like the fake numbers and positives are real, people have this idea that imaginary numbers are fake and real numbers are real. I mean, it's in the name. It's really a shame. Should have called them like X numbers and Y numbers or something. Okay, so that gives us this. I think I'm going to search for a picture of a number line. I want to make sure that it's... Oh, perfect. Ugh. Yikes. No, that one was indicating some irrationals and where they are. Okay, do I have to make a number line? I shouldn't have to make a number line. I just want a number line with 0 in the middle, negatives on the left, and positives on the right. Is that too much to ask? Oh, it's about vectors. I wonder if I can just crop that out. Please have arrows. Oh, good, arrows. All right, so I'm gonna crop those out. Ah, dang it! That little A is still there. Can I get you out? Got it. Okay. All the numbers on the line are considered a real number. Okay. Okay, this is good. This is good from a number line point of view. Let me see what kind of exercises they have for those. I would really like to... really like to be able to prove that a number is irrational without like ripping their brains out on the second day. I see you guys talking about the imaginary numbers. There is a way to physicalize imaginary numbers, but it's obviously very, very imaginary. But I'm gonna have to save that for actually in that section. I love that demonstration so much. Oh, man. Okay, so here we are. Commutative, associative, identity, inverse, distributive. Okay, so there is an addition and subtraction property of equality and a multiplication and division property of equality. I'm going to do a what is it with the number line right here. Okay, so what are numbers? Next up, what are operations? Oh no, I don't think I can fit this into 2 days. Can I? Sure I can. I can do that. Okay, so... no, title. So some of you might like this. Who am I kidding? You'll all like this. Dang, where's my... I can't remember where my layout menu is. Shoot, this is embarrassing. There we go. All right. So what are the operations? Insert special characters. Well, I guess I don't really need them for plus, small plus. Seems dumb. I should have just... Anyway, let me do times divide. That's weird. There's no division. There it is. I did write actually division. All right. Like, yeah, I know that's the symbols, but like, what are they really? Okay, so what are the operations? Here's how we're going to conceive of them, class. Arrange tools. Oh no, where was it? Doggone it. It was there. Apply layout. Addition is number line. Is that 2 words? Number line sliding or shift. Shifting. Okay. Start with 2 number lines in the same position. Okay. Copy paste time. Just going to keep using this number line from before. Here we go. Okay, 2 number lines in the same position. I guess I should label them. Maybe one of them is A, one of them is B. Oops. A, let me make that nice and easy to read. The color be green. Stop it, mouse. You're embarrassing me. Okay, so we got A. That one will be green. And I guess they'll just both be green. B. All right, so two numbers, two number lines, A and B. All right, now I have to duplicate this slide. Now shift one of them 2 units to the right. All right, now I just need to move B so that the 0 is underneath the 2. See? Shift one of them 2 units to the right. Okay. So the best way to understand what addition is and what addition does is by relating these two number lines to each other. You can take A as its original position, B as its new position. Okay, actually that would make it subtraction then, wouldn't it? Yeah, I better shift it to the left. All right, number line, you're coming with me. All right, I think I want the B from the original position so it didn't look like it moved. There we go. 2 units to the left. Two is now where 0 used to be. Guess I can make that +2 and I'll color it blue as well. See? Shift one of them 2 units to the left. +2 is now where 0 used to be. The best way to express the relationship between these two number lines is with addition, as in top one +2 equals the bottom. And this is another way of seeing how addition and subtraction are symmetric, because you could just shift the other way or go from B to A, and you have the same idea. Okay, now shift one of them 2 units to the left. +2 is now where 0 used to be. I didn't line that up quite perfectly. Oh, come on. Better. Okay, so best way to express relationships between those two number lines. Yeah. Best way to express the relationship between those two number lines is with addition. Not only that, but this is a great way of expressing domain and range in terms of functions, as in A would be the domain, B would be the range. Best way to express relationship between those two number lines is with addition. It is also symmetric if we reverse the comparison or went right instead of left, we would be using subtraction. Awesome. So the specifics of I put 2 where 0 was basically is treat 2 as if it were the center. Everything has had 2 added to it. That's good and all, but I think that might just be a bit out there for everybody. All right, so now multiplication. Duplicate the slide. So multiplication is number line stretching. And actually it's not stretching, it's rotation. But we'll get there. In the same position. Duplicate slide. Alright, now shift one of them to, alright. Now stretch one of them so that how did I phrase that first one? Okay. So that 2 number integers line up again. So I'll stretch A this time. So what I'm going to do is distort A. All right, I got to be able to reach this here. Almost there. It's really nice to be able to deform this. So I have a plane of glass. It is pane of glass. It's actually an empty picture frame. And when I used to teach this, I would actually cast a shadow on the board with a projector, so I could cast the shadow of a number line onto, oh, it's so close. It needs to be just a little bit bigger. I cast the shadow of a number line onto the board so that the 2 number lines would match up, and then I would rotate the glass, and you could actually see the shadow distort, and it would, too big. Oops. There we go. Stretch one of them so that 2 integers line up again. Got it. And what was the best way to express? Got it. The best way to express the relationship between the 2 number lines is with addition. Oh, sorry. This was multiplication. Duplication. Let's see. I have no idea why 5 people are watching right now. You're all very polite. Just watching a nerd do math. Best way to express the relationship between the 2 number lines is with multiplication. Of course, it is symmetric. So if you had shrunk it instead, or reversed the comparison, it would have been division. This reinforces why addition and subtraction are the same thing, and why PEMDAS is nonsense, because it puts addition before subtraction. No. That addition, it's just all addition. All of it. Okay. So, speaking of which, I had previously stated that multiplication is just repeated addition. That is a great way of interpreting mathematical expressions if you're trying to evaluate them, but in terms of interpreting this picture, ooh, it's a little tough. I don't think it'll come up though. But if I were to be asked that, I think I would say that it's repeated addition in the sense that each of these spaces is a repeat of these spaces. Could probably work that in there somehow. I wish I could animate this stretching. Boy, I wish I could animate that stretching. That would be cool. Okay. Multiplications, number line stretching. So I do have this on Pear Deck. I had some interactive slides, and now the interactions are all gone. Or at least I haven't had any in a little while. So let me see what I have here. Number properties. Commutative. Got it. Associative. Identity inverse distributive. I am starting to worry that I might be packing too much into one day. What are numbers? Okay. Naturals, integers, rationals, irrationals, reals. Okay. Operations, addition, number line shifting, line stretching. Okay. So what kind of do I still have the text up? Yeah, I do. These properties. All right. Properties. So how the heck is this commutative? Let's see. Addition and multiplication commutative. Just trying to think of how to express that in terms of the language that I've established. Number proper, no, not number properties. Are they number properties? Commutative. Why would that be a number property? Numbers aren't commutative. Operations are commutative. Right, I see. They're 4 real numbers. Got it. Okay. Right, that's okay. That's where I was going with that. So addition has an identity. Okay, good. Properties of addition. That would be, I guess I can make a bulleted list. Ah, I know what I'll do. Addition is commutative. It is associative. Where am I here? Identity inverse. Got it. Identity inverse. Okay, so let's make those bigger. This is going to fill the slide. wonder if that size is going to fit. We'll see. Come on now, make it match. Why don't you match? Also, that's my mouse wheel, always taking me to different places I don't want to go. All right, commutative, that would be, oops, A plus B equals B plus A. Okay. This format looks really dumb. I'm ditching this format. I'm going to make a table. Insert table. Let's see. So it was 4 of them. Commutative. Oh, great. Now I can't read it. Let's make this be lighter. Okay, so here's something that I really don't like about this planning. This is taking a really long time. I would rather not have to spend this much time on every lesson. Associative identity. Yeah, I shouldn't be spending 2 hours on a single section. It's a problem. It's a problem. But I'll solve it later, not right now. A plus B equals B plus A. In other words, the order doesn't matter. Okay, associative, and that is where the order among 3 doesn't matter. I want to see how it expresses it. Okay, just puts parentheses around. So, ooh, I'm gonna be able to fit this. A plus B plus C equals. All right, yeah, I'm gonna need to make the size a little different on this. Oops. There we go. Identity. Okay, so the concept of an identity is that there is some number which has no effect. It's all right. Identity. So an inverse A, oops, plus negative A equals 0. Awesome. There are no such properties for subtraction. You just have to treat them all as negative numbers. It's only for addition. All right, I'm gonna duplicate this slide, move it to the end. Okay, so note for myself, the next time I do a planning live stream, I need to do one where it's a bit more of an exciting plan. This is the kind of thing I really don't need to be doing for a show, but hey, y'all are here and I appreciate it. Properties of multiplication. And now I need a symbol here. Insert special characters. Times. I really hate using this X for times. I wish I could use a dot, but you know, it's what people know. It's commutative. It's associative. Ooh, rough. Oh no. Oh, tell me it's not true. I'm going to need to make it a little bit wider. So I dare not change the size. Stop it. There we go. Perfect. Don't change it. And this would be times 1. And this would be times, and then the fraction 1 over A. Oh no. How? No. That's not going to do. That's not going to do. Okay, here's how this gets done. It's an add-on called a Quadio. Oh no. Oh, I can't use it in this. Shoot. If you're a teacher, free for teachers program. That's interesting. I guess I'm doing an ad for Quadio in today's live stream. Today's live stream brought to you by Text Help Read and Write Quadio, whatever it is. I do K through 12. Ugh. Don't think I want to broadcast me giving all that info, so I guess I'll put in 1 over A and do that later. Equals 1. Okay. Last up, distributive property. I think I had a visual representation of these properties, and I'm not sure where they are. I wonder if they are here. I should have like a download box. No, it's not that. Drive down. Is it this one? No. When I got my when I returned my work computer, I saved all the files from it. I downloaded them all in a big oh, no, this is terrible. Here we go. No, not there. Almost. No. Huh. Well, that's sad. Alright, I guess I'll find that properties of addition. So I want to be able to do the distributive property graphically. So the distributive property will be the last thing, and that'll be the end of this lesson. I need to not do for future lessons like this. This is terrible. The distributive property combines multiplication and addition, and the rule looks like this. Oh, let's make this be the same size. Stop capitalizing everything. A times B plus C equals A. I know it's not necessary to put times everywhere. I just want to be super duper clear. A times B plus A times C. Yeah, I think I need to make this centered and bigger. The distributive property combines multiplication and addition. Okay, this can be understood graphically as well as verbally. This can be understood graphically graphically? It's with a picture. Graphically, sure. Graphically and verbally. So let me just make a little translation. Oops. Okay, so I'm going to make this be smaller and green. A of B and C is A of B and A of C. There we go. Oh, that's going to be too much. Alright, so I put 3 spaces in. Just 2. Still too much? Still too much. Just putting a single extra space in. There we go. A of B and C is A of B and A of C. Okay, I need to space this out a bit. Just getting the spacing here so that when it's centered, everything is underneath of what it's supposed to be. Shoot. This is quality content right here. Okay. It's pretty close. Alright. You know what? I've color coded this wrong. I need to color code things so they match vertically. B can be red. C can be blue. No. Go with that. Okay, A of B and C is A of B and A of C. In other words, a pair of socks and shoes is a pair of socks and a pair of shoes. That's the idea. Okay. I think that's actually going to do it right there. Okay, so what are numbers? Alright, how long has this cursed live stream been going? My computer just went to sleep. Alright, so it's been an hour and 48 minutes. I cannot spend an hour and 48 minutes on a lesson like this. I've got to pick up the pace somehow. Anyway, it's 7:17. I think I better make some dinner or something. So, if you stopped in even for just a little while, thank you very much. I appreciate it. But I tell you what, I will see this through. I'm going to post this in the classroom, and that'll do. So let me put this in the Algebra 2 folder. go to this one where I have the classroom. Going to, oops, that's supposed to be in this topic. It's supposed to be in the topic of week 1. There we go. So create material number 3. Real number theory. Walk through categories of numbers and properties of operations. We'll add what are numbers? Okay, so looks like what I need to be doing is 1, making better plans for these live streams, and 2, not spending an hour and 50 minutes on a single section. I'm not going to get ready for the school year like that. Anyway, how else can I end this stream but it's been real? Thanks for stopping by.